Today I'm going to be talking about identifying characteristics of quadratic functions, and this is the first day of this section. I split it into 2 days. So first off, it says graph the function, label the vertex and axis of symmetry. All right, so first of all, we need to figure out what kind of form is this function in. And if we take a look at this, this is in vertex form. And we've seen vertex form. We know how to graph in vertex form. So we know that the vertex for this is 7, -1. Okay, so we know the vertex is 7, -1. And from the exploration on Friday, we were able to identify an axis of symmetry. And the axis of symmetry is always the x value of the vertex. And it's an equation of a line. So we always have to write x equals 7, because that's going to be a vertical line on 7. So let's graph x equals 7. And then let's graph our vertex, which is 7, -1. Okay, so we have that piece of information. Now I'm going to do a table of values. I'm just going to do a quick one because I already have these pre-done. So if I plug in 6, I'll get 0. And if I plug in 5, I'll get 3. Okay, just plugging into the actual function. Okay, so I'm going to graph 6, 0. 1, 2, 3, 4, 5, 6. And the reason that we draw this axis of symmetry is that you can see this point is 1 unit away from the axis of symmetry. So we can do the same on the other side and graph the reflection of that. We reflect over the axis of symmetry. And we can do the same thing for 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. This one's 2 away, so I reflect 2 away from that one. So now we have our parabola. I've labeled the vertex. I've labeled the axis of symmetry. So there you have that in vertex form. Let's do another one in vertex form. Since this is in vertex form, the vertex is -1, -3, and the axis of symmetry is x equals -1. So let's graph x equals -1. Let's graph our vertex, -1, -3. And I already picked 2 points ahead of time. And I picked a -2 and I picked a -3 for this one. And I plugged it into the original function and I got a -1, 5. So let's graph those. So -2, -1, and I reflect over onto the over the axis of symmetry, and then I do -3, 1, 2, 3, 5, 1, 2, 3, 4, 5, and we reflect over by the 2. Make a nice curved parabola. That one's a little stretched out. Okay, and so that's our parabola in vertex form. Okay, well, what if our function is in standard form, like this one? This one is standard form, which is y equals ax squared plus bx plus c. And this is in standard form. So if we have a function in standard form, we're going to have to find our information differently. And whenever we're in standard form, we always find the axis of symmetry first. And the way of finding axis of symmetry is x equals -b over 2a. So we can take -b over 2a to find our axis of symmetry. So we're going to do that. Our b is a -6, so that's going to turn into a +6. And 2 times 3 is 6. So our axis of symmetry is x equals 1. Okay, so let's draw that, x equals 1. Now the axis of symmetry always goes through the vertex, so we actually already know our x value of our vertex, which is 1. To find our y value of our vertex, we are going to plug in the value for 1 into our original function and analyze for y, or simplify for y. So we're going to do y equals 3 times 1 squared minus 6 times 1 plus 4, and we get 1 again. So So our vertex is 1, 1. So that's how we do it a little bit differently. We have to do the negative b over 2a to find our axis of symmetry, and then we have to find our vertex by plugging in the x value to get our y value. So we're at 1, 1. And then, of course, we do a table of values again. I picked, let's see what I picked. I picked 0, and I picked a negative 1. And I plugged it into the original function, and I got 4 and 13. So I have 0, 4, reflected over by 1, and then negative 1, 13, which is way off the graph up here. Okay, and then we are going to make a nice curved parabola right there. So when we do have standard form, we have to find the axis of symmetry first, which is the negative b over 2a. That's the value of the x of the vertex. Plug it in, find the y, then find 2 points using a table of values, and then reflect those over the axis of symmetry. All right, let's see another one like this. This one has a fraction in it, so it can be a little tricky when you put it into your calculator. So make sure you plug this into your calculator correctly. So this one is in standard form, and so our axis of symmetry is going to be x equals negative b over 2a. So that's going to be 4 over 2 times a negative 5 halves. So be careful with this one. These two cancel out, the 2's cancel out, and we get a negative 4 fifths, okay? But when we graph, it is so much easier to graph in a decimal. So I would say the axis of symmetry is x equals a negative 0.8. So we're going to graph a negative 0.8 as our axis of symmetry. We're a little bit before the negative 1. Okay? Now what we can do is we can find the vertex by plugging in the negative 0.8 into our original function. And like I said, make sure you are really careful when you plug it into your original function with parentheses where they need to be and negatives showing up where they should be. And you will get a 0.6 as your y value for that one. That is the correct answer. If you need help with your calculator, just ask me. So we have a negative 8.6, which is about here, okay? And then we do a table of values, and let's see what I got for the table of values. I got x and y, and I chose 0, I got negative 1, and then I did 1, and I got a negative 7.5. Okay, so let's do 0, negative 1, flip that over, and then 1, negative 7.5. 1, 2, 3, 4, 5, 6, 7.5. So about full 2 over, about there. Okay, and then reflect that over and bring that down. Okay, so those are both examples of graphing in vertex form and in standard form. And you've got to remember your x equals negative b over 2a in your standard form. All right, I've got a word problem for you. This is our last one. It says the path of a shot put released at an angle of 35 degrees can be modeled by y equals a negative 0.01x squared plus 0.7x plus 6, where x is the horizontal distance in feet and y is the vertical distance in feet. Find and interpret the coordinates of the vertex. Well, first of all, let's draw this, okay? So we have a shot putter, and his shot put is going to be right here, and he throws it at a 35 degree at an angle of 35 degrees, okay? Now the 35 degrees isn't going to factor in to finding our vertex because they've already written the function for us. They've already written the function for us. So we don't have to change anything with the 35 degrees. So let's determine what the x and the y value stand for. So the x is how far away the shot put is after it's been thrown. And the y is how high the shot put gets when it is thrown. Okay, so what we're going to do is to find the vertex, we use our x equals negative b over 2a, oops, which equals 35. Okay, so our vertex is 35, and if we plug 35 back into our original function, we get 18.25. So that's our first part. We found the vertex, but now we have to interpret it. We have to use words, okay? So interpret this. It says when the shot put, so let's figure out what the 35 means. 35 is the shot put is 35 feet away from the shot putter and is 18.25 feet at its highest. So we can evaluate that vertex in words.